this video, we are going to see about full wave rectifiers. In full wave rectifiers, there are two types of rectifiers, namely center tapped type and bridge type. In this video, we are going to see about center tapped type. Let's list out the contents of this video. First of all, we are going to see about the full wave rectifier, that is, what is a full wave rectifier. Next one is we are going to see the construction of the full wave rectifier and its operation and output waveform. Now let's see what is a full wave rectifier. As I already told you that a full wave rectifier is a circuit that conducts both the half cycle of the AC input voltage. So we already know that the AC input voltage consists of positive cycle and negative cycle. So during the full wave rectification operation, we can get the pulsating DC output as during positive cycle also we get the output, and during negative cycle of the AC waveform also we get the output. Let's move on to the construction of the full wave center tapped rectifier circuit. In this rectifier circuit, to rectify the both half cycles of the AC input voltage, two diodes are used for this purpose. Let's see how to construct a full wave center tapped circuit. For this, first of all, consider a transformer, which is a center tapped transformer. Now you can see that in the secondary of the transformer, here you can see it is center tapped. And we can place two diodes across the two terminals of the secondary of the transformer. Now place the load resistance RL. From the circuit we can see that the diodes feed a common load RL with the help of a center tapped transformer. Let's move on to the operation of full wave center tapped rectifier circuit. For that, consider two terminals across the secondary of the transformer as A and B. Now let's consider the single phase AC input waveform. During the positive half cycle, what happens is that the A terminal becomes positive and B terminal becomes negative. So the diode D1 becomes forward biased and D2 becomes reverse biased. So the diode D1 acts as a closed switch and the diode D2 acts as an open switch. Let's see how the current flows across the load. So as I already told you that the diode D1 only conducts and diode D2 goes to off condition, or it acts as an open switch. So the current flows across the upper portion of this circuit like this. Now we get the only positive half of the cycle across the load as output DC voltage. During the negative half cycle, the terminal A becomes negative and the terminal B becomes positive. The polarities across the center tapped transformer secondary is shown. As the A terminal is negative, the diode D1 goes to reverse bias condition and the diode D2 becomes forward biased. Now the diode D2 acts as a closed switch and the diode D1 acts as an open switch. Now let's see how the current flows across the circuit. Now the current is flowing through the lower half of the secondary winding with respect to the load. Now we get the output voltage as shown in the picture across the load. In short, during the positive half cycle, the current flows across the upper portion of the secondary of the transformer with respect to the load, and it gives the load voltage as like this. During the negative half cycle, the current flows across the lower portion of the secondary of the transformer across the load, and it gives the DC output voltage like this. In short, for the given AC input voltage, during the positive half cycle, the diode D1 conducts, and during the negative half cycle of the AC input waveform, the diode D2 conducts, and so on. Thank you for listening this video.